The Fermi paradox. Where are all the aliens? If the universe, or our galaxy, with its billions of stars, contained other technological civilizations, using our own rapid development as an example, we should expect to find some signs of their existence. Unmistakable signs in the form of unnatural radio patterns or signals. Given our own growth and curiosity, it doesn't seem unreasonable to believe others wouldn't one day build huge structures that we might detect from Earth. Given the amount of time and planets available, this also seems plausible, if not likely. But, to all our efforts so far, we still have found no obvious signs. This is the paradox, the idea that surely there must be more advanced civilizations out there. Given the time available, the universe should be full of such populations. So where are they? A simulation doesn't need to simulate humans as we know them, but just a consciousness capable of asking the same questions, in an environment with the physics to test them. The scaling factor. What if we were currently part of a technological race? An almost completely invisible side effect, unnoticed by everyone, yet could make the difference between becoming a spacefaring civilization or not. This is the competition of size and scale. The ever smaller versus the ever larger, the byproduct of an ever-evolving technology that dictates our direction as a species. The race to build the immense infrastructure needed for off-planet colonization versus the technological race to build ever more powerful computers and AI. This competition leads to a paradigm with a plausible singularity at both outcomes. Successful intergalactic travel versus the perfect simulation. The problem with this race is that it is by no means fair. Our ability to fabricate physical structures doesn't double every year or two like microprocessors do, leading to buildings twice as big and twice as strong as the year before. Recent leaps in GPU-based learning and AI have shown how quickly development in this area can happen, evolving at hundreds of times the speed of computer chips. Though our ability to build large things has had several thousand years head start, the scale at which it can be utilized progresses at a comparatively glacial speed. It is a misconception that humans need to upload our consciousness to interact with the simulation, though that might happen if that is the aim. But it is not at all necessary. A true simulation is a physics universe simulator. It simulates the physics that are capable of creating what we know as everything, including ourselves, either through evolution or a fixed starting point. Much like the physics in our universe created us, simulated physics creates simulated us. The likelihood of you existing in the simulation is only ever proportional to the number of simulated beings ever versus the number of non-simulated individuals. If the simulation is physically correct, you would never know on which side you lived. If we tried to draw a timeline for either the complete domination of our solar system or our voyage into interstellar space, it would be on the timeline of hundreds or thousands of years. This is the singularity at one end of the spectrum, the minimum viable indicator to the universe that we exist. That is what any civilization would need to do to break the Fermi paradox. Though on the other end of the spectrum, the technological race to advance smaller, more powerful hardware and software continues. The paradox of who wins may be written in the stars. It may seem far-fetched to some, a fully simulated universe, even laughable. But the fact of the matter is, you are in one right now, one capable of simulating the world as you know it and capable of creating a universe of your own choosing. The human brain, and probably that of most animals, is just a simulator, an organ that can take external stimuli and form a picture of the surrounding world internally. You do not see the photons that hit your eye, but an image created through chemical signals, reformed into an image deep in your brain. The same thing happens when dreaming. Your tiny, warm, wet, squishy brain can simulate a time and space inappreciably close to reality. The Fermi paradox, I'm sure, is not actually a paradox. Rather, our inability to currently build the machinery capable of making the observations needed to locate and view the signs of technology an alien race might display. And maybe the need for making things big enough to be viewed from such great distances is unnecessary and difficult. As a technology progresses, the need for lower energy requirements develops, further reducing possible detection. It could also be a scale race, in our building larger telescopes versus aliens going more compact. Maybe an alien telescope will be the first thing we see, and them ours. We might assume that if we can't see any other life in the universe, then the same would be for alien species, or at least some. The reality of the miniaturization of technology could be obvious when reflecting on one's own techno-fingerprint, resulting in different approaches to the situation. Rather than running around in the dark looking for answers, any advanced and bored enough civilization could signal others to their existence. This could mean that detection is not the issue, but rather the intelligence needed to notice the signal at all. It could be the advancement in artificial intelligence that make the difference, and our species just hasn't reached that point yet. Our current mark on the universe is immeasurable. There is still no timeline for true space habitation, and until we can meaningfully alter the spectral signature of our star, it's likely no one will ever know we are here. Standing on the edge of the AI revolution, it's hard to know if this paradigm will continue. We might find large-scale automated manufacturing could tip the scales. I have no doubt in our ability to slowly continue towards a future in space, though how much of that remains to be seen. Still remains to be seen. The late great filter. Throughout life on Earth, there has been natural disasters or events that have caused bottlenecks on biological development. Almost complete extinctions multiple times, a restart for life. These are the great filters. There is thought to be at least 5 main extinction events on Earth, where over 90% of life was destroyed. If any one of these events would have been any worse, we wouldn't be here today. But also, if they had never happened at all, then the path that led to our development may never have taken place. These are the natural hurdles for all life to overcome. The late great filter is an event that is yet to come. An event, natural or not, that stops intelligent life from growing to a point that it makes a visible mark on the universe. As a species, we almost have a universal dark awareness of this filter, and it seems unimaginable to most that humans could exist for thousands or millions of years. The closer a population gets to numbers needed for dedicated space programs and advanced technology, the easier it becomes to destroy itself. Currently, even the combined efforts of the world's greatest scientists with unlimited budget and manpower could not reliably build a craft capable of manned interstellar travel or a long-term habitat on another planet. But we could easily destroy ourselves many times over with an assortment of weapons, from biological, chemical, nuclear, environmental destruction, artificial intelligence, and unavoidable catastrophe. This is thought to be the late great filter, much like a typical environmental extinction event. This could be an almost natural, unavoidable symptom that is just a byproduct of the technological arms race. It could be that this filter is common to many intelligent species. As evolution enables diverse means to defend and feed oneself. The arms race started long before any deliberate choice. When speculating on the reasons for the paradox, it's hard to go past hard physics and the raw physical difficulties of space travel, from propulsion energy requirements, radiation and high-speed particle shielding, time dilation, communication and resources. As well as the effects the crew would experience, like health issues in zero gravity, alienation, population decline, deficiencies, stress and disease. We just don't know what the realities of deep space survival are, and we have no meaningful ways to test them. Our furthest craft, Voyager 2, after 46 years of travel, is still well within the influence of our star, and will be for thousands of years. Space is large. It's dark, cold, highly radioactive, full of high-speed debris, distorts time and is negatively pressurized. The opt-in cost for space travel is extremely high, and there might need to be some big profits to make it even seem tempting. So, what might we expect to see? And what's missing? Just about every day a new exoplanet is discovered, in almost just the right position for life to flourish. But these observations are indirect measurements of the planet based on its effects on its star, and sometimes a spectral graph of the atmosphere during transit, but no direct observations. We can make assumptions based on this data, but only broad guesses to what it means. One hope in finding signs of civilization is in detecting anomalies in the star itself, either through detecting infrared heat emitted as a byproduct of capturing the star's light, or obvious signs of signaling through salting stars with non-naturally occurring matter, like rare heavy metals with short half-lives. These indicators are well beyond our own current capabilities, but this is the scale of the things we need to look for to have any chance of viewing life outside of our solar system. Przybylski's star is one of several stars that does in fact show an unusually high level of rare metals like cesium and uranium, and has been hypothesized as a candidate for alien alteration by SETI, though simultaneously not ruled out as natural phenomenon. Our collection of unusual, almost unnatural systems continues to grow. Though we don't understand enough about space to give definitive answers to these questions, we may one day find out. This is just my quick take on this interesting paradox. Lack of radio signals aside, this is just a handful of a million hypothetical reasons why we don't see intelligent life displaying technological signatures, when according to even the smallest of probabilities, given the large number of planets and time, we should. Thanks for listening. I'm Mode 1. Please like, comment and subscribe to keep me motivated.